Welcome to Learning to Engineer. If you want to measure 50 volt, which voltmeter will you choose? You have to consider the accuracy of the device, the precision of it, the range, threshold, sensitivity, drift and dead zone and so many other parameters before you pick one device. If you want to understand more about these parameters, quickly check this link and then come back to this video. First, we will understand the different kinds of errors that occur while measuring. Later on, we will understand how to pick a device when you know the range of the measurement, or when you probably want to measure this range of voltage, which voltage will you measure and what are the parameters to consider that. Let's get started. These are the three kinds of errors. Basically, when we do some mistake, it may be at work or maybe at home or anywhere, what we do when we make a mistake? We blame someone, right? Who is responsible for it? We may blame ourselves. Those are gross errors, human mistakes or careless mistakes. And next one is the systematic errors. This is the kind of errors which keeps repeating based on certain conditions. And these errors are basically the instrument's errors. So when we make a mistake, if we blame ourselves, it is gross errors. If we blame the instruments or the tools that we use, that is systematic errors. If you just say it's just God's will that this mistake has happened, or the source is not known to you, those are random errors. It can occur, it might occur during some experiments, it might not occur during some other experiments. The cause of the error is unknown. Those are random errors. We will first see gross errors or human mistakes. It might be due to carelessness, it might be due to the shortness of eyesight in that observer or something else. The gross error doesn't repeat over time. If an observer is noting down 10 readings, he might make mistakes in one or two of them, but not all of them. Those are gross errors. These are just the careless mistakes of the observer. Now we'll see the systematic errors. When you are measuring the pressure using Bourdon gauge, the atmospheric pressure or the atmospheric temperature might affect the components which is present inside it. The stiffness of the rubber that is present inside the device might be different at different levels of temperature. Today the temperature might be slightly hotter than yesterday, so the reading taken today might be slightly different from what was taken yesterday. Those are environmental errors. Basically they caused due to the environmental conditions like heat, temperature, pressure or the humidity and other gaseous levels. So these are environment errors. We need to make sure the environment is same and sustainable throughout the experiment. Maybe at the start of the experiment, air's humidity might be different, and as the experiment progresses, the humidity might change. So under these conditions, we will be getting some errors. Those are environmental errors. Next is the observational errors. When I say it is observational error, I am not blaming the person. I am still blaming the device. Here, the gross error is basically due to the person who is doing the experiment. But observational errors is slightly different. When you are observing a reading, let us say for example, this is the ammeter scale and this is where the pointer lands and the reading says 10 ampere. I am looking at this reading from left side. So it might occur like the pointer is at this position when I am looking from left. Whereas when I am looking from right, what happens? The pointer might appear to be at this position. So I am still seeing it correctly only, but my position or the viewpoint or the perception is different. The perception is wrong. I should be looking at this right at 90 degrees. Only then I can get the correct reading of the ammeter. This is not gross errors because I am still observing it exactly right. I am not making any careless mistakes. I am looking at it, it says 11 ampere, I am noting 11 ampere. Or if it says 9 ampere, I am noting 9 ampere. Those are observational errors. These are also called as parallax errors. And next is the instrumental errors. The instrumental errors are basically due to different things. One is due to the shortcomings of the instrument. Maybe the instrument is very old, or the parts which are there inside the instruments has to be replaced. Maybe the spring's tension has changed. While buying, the spring will be very taut, so that when the ammeter is moving, it will be damping at the right position. But over time, due to wear and tear, the spring's stiffness might differ due to the age factors and all. The tension of the spring will loosen. So when 10 ampere of current is passed, the damping that is offered to this pointer will be very less actually. So basically, if you are wondering what I am talking about, I am just talking about the spring that is here. Basically, you will have a PMMC device here, and due to the currents effect and due to the magnetic field that is affecting it, the pointer will move. That is basically the working of any kind of a meter. But if this spring's tension is more, what will happen is it will be stopping at exactly the right position. But due to wear and tear, when the spring is loose, the 10 ampere, the actual current might be 10 ampere, but because of the looseness of the spring, you will be getting slightly higher values than expected. These are called as instrumental errors. There is another cause for instrumental errors. It might be due to loading effects. If I am, say for example, I am doing an experiment and I am finding the value of the resistance. When I am experimenting with less values of resistance, my error will be very less, or it will be something close to 0. But say for example, I am using higher ranges of resistance for my experiment. Under those conditions, my meter will still work, but still the reading will give me errors. Those are called as loading effects. Consider this situation to understand better. There are two resistances, 100 kilo ohm and 50 kilo ohm, connected in series with 150 volt. An voltmeter with sensitivity 1000 ohm per volt is used to measure the voltage across the 50 ohm resistor. Find the error in voltage due to the loading effect. This is the scenario that is given to us. We need to measure the voltage across this 50 kilo ohm resistor, and we are using a voltmeter with sensitivity which is 1000 ohm per volt. So in that case, what is the loading error? That is what is the question. Before we find out the loading error, we should first find out the true value of measurement, or the true voltage that appears across this resistor. Only then we can apply the conditions given and then measure the voltage using the meter, then calculate the error. First, we will find out the true value of the voltage that is measured. Just by using voltage division rule, you will be able to find the voltage across it. If you do not know this rule, quickly check this link where I have explained you the voltage division rule in enough detail. So once you get a good idea about that, you can continue watching this video. So basically, if you want to understand this problem, you should understand the parameters like accuracy, precision and sensitivity, which is already linked with this video. And then you need to know voltage division rule in order to find out the true value of this resistor. So by voltage division rule, the voltage across the 50 kilo ohm. Let me label these terminals as AB. VAB is 150 volt times 50 kilo ohm divided by 100 plus 50, 150. So the voltage across AB will be, the voltage across AB is 50 volt. So 50 volt appears across this resistor. This is the true value. Let me mark this. This is the true value. Now we are going to apply the meter across the terminals A and B, and it is given that the sensitivity of the meter is 1000 ohm per volt. So this is the sensitivity of the meter that we are going to use. So if you want to measure 50 volt of voltage, what will be the voltmeter's resistance? It is 100 ohm times 50 kilo ohm. So now we are connecting the meter across it. So when we are connecting, we have an additional resistance that is parallel to this setup. It is not just 150. You have another 50 kilo ohm in parallel with this 50 kilo ohm. So the effective resistance will be 100 plus 25, 125. The effective resistance will be 100 plus 50 parallel with 50. So the effective resistance is 125 kilo ohm. So across 125 kilo ohm, 150 volt is going to get shared. So 150 volt will be shared between this and this pair. The voltage that appears across it is same as the voltage that appears across the voltmeter, and this voltage is affected by the additional resistance that is connected in this circuit. So the effective resistance of these both will be 25 kilo ohm will be the effective resistance across these two pairs alone. So 150 volt is shared by 100 kilo ohm and this 25 kilo ohm. So 30 volt is the voltage across this pair when you connect the voltmeter. But what is the true value? True value is 50 volt. So the error will be 50 minus 30 divided by 50. So this error is 40%, which is huge because the true value is 50 volt, and when you connect a meter, the voltage changes because of the meter's resistance. So we need to pay attention to the sensitivity of the device. Higher the sensitivity is, greater will be the accuracy. So when you are measuring the voltage across this, you have to select a suitable meter which will be able to handle the load, as well as the resistance of the voltmeter should not impact much. The resistance of the voltmeter is supposed to be infinity ideally, but that is not possible. So the resistance of the voltmeter should be as high as possible so that it will give you a better accuracy. This sensitivity is very poor actually. So per volt 1000 ohm only is getting changed. So if say for example I am using a voltmeter with better sensitivity, what will happen is when the voltmeter sensitivity increases, this resistance will increase. When this resistance increases, the equivalent resistance will increase. The equivalent resistance in this case is 125 kilo ohm. So the equivalent resistance will change. So is the load that is connected to the voltmeter. So basically when two resistances are in parallel, the equivalent resistance of two parallel resistors will be smaller than the smallest resistor. That is what is equivalent. Say for example you connect 50 ohm in parallel with 100 kilo ohm. So in that case the effective resistance will be lesser than 50. So that is what is the concept. So it should be so great that the effective resistance of these both should be equal to 50 kilo ohm. Only then what will happen, the voltmeter will be supplying voltage to the 50 kilo ohm resistor. So ideally if you want to say the effective resistance of two resistance, one is 50 kilo ohm, the other one is the voltmeter's resistance. So the effective resistance of these two must ideally be 50 kilo ohm. So in other words, the resistance should be infinity so that no current passes through the voltmeter, but the entire current passes only through the 50 kilo ohm resistor. This is the ideal condition, but practically the voltmeter's resistance should be as high as possible so that the effective resistance of this comes closer to 50 kilo ohm. Let us say for example, I am using a voltmeter whose voltmeter's resistance is let us say 200 kilo ohm. It is 4 times more capable. Now I am saying that RV is 200 kilo ohm. So let us back calculate the sensitivity. I am just saying RV should be 200 kilo ohm. So in that case the modified circuit will be so let's calculate the equivalent resistance of this pair. The equivalent resistance will be 50 into 200 divided by 50 plus 200. The effective resistance will be 200 times 50 divided by 250. 40 kilo ohm is the effective resistance. 40 is little closer to 50. But here what is the effective resistance? 25 kilo ohm, which is half of it. That's why the error is nearly half of it, which is 40%. Now I think the error will be reduced. Let us check. So what is the voltage across A and B? voltage across AB will be 150 times 40 divided by 140. So the voltage will be the voltage across this pair is 42.85 after I connect this voltmeter. Without any voltmeter, under the normal conditions, if we calculate the voltage across this pair, the voltage is 50 volt. This is the true value. But now we are getting the voltage across AB as 42.85, which is little close to 50, but still it is not the expected performance. But in the earlier case, what was the voltage across this? The voltage across this was 30 volt, which is far less. So compared to that, this voltmeter gives a better reading. So let us first find out the error. The loading error will be 50 minus 42.85 divided by 50 times 100. See, the error is 14.3 now. Now the error is 14.3. Earlier the error was 40%. Now take it as an exercise. Consider that the voltmeter's resistance is 300 kilo ohm. Okay, so when the voltmeter's resistance is 300 kilo ohm, calculate the voltage across this pair and then find out the error. I am sure the error will be much lesser. So take it as an exercise and all of you do. Okay, so now let us back calculate the sensitivity of the voltmeter when the resistance is supposed to be 200 kilo ohm while measuring 50 volt. So if we try to back calculate, the sensitivity should be, sensitivity is output by input. So this is 200 kilo ohm for 50 volt. So what is the modified sensitivity? 4000 ohm per volt is the modified sensitivity. Earlier, the sensitivity was just 1000 ohm per volt. It should be 4 times that, which is 4000 ohm per volt, in order to get an error of 14.3%. So in that case, also in the case where you are calculating the voltmeter's resistance to be 350 kilo ohm, I will just put it as RV dash. If the resistance is, if this is this, find out VAB, next find error and also find the sensitivity of the meter. This is the exercise for you. Quickly take a pen and paper, quickly solve. It will only take 2 or 3 minutes for you. After you find out the answer, let me know your thoughts in the comment section. Just type the answer in comment section, and if you have any doubts or if you have any questions for me, you can also type it in the comment section. You can also mail to learningtoengineer@gmail.com. Subscribe to my channel for more updates and do give a thumbs up if you like this video. Thank you.